Hey physics, let's continue our study of the atom. So this form is based on J.J. Thomson's experiment that led us to the plum pudding model. And the big discovery there was the discovery of electrons. So let's go in to see how to answer these questions here. So a cathode ray machine shoots a stream of glowing particles from the negatively charged cathode to the positively charged anode. What are cathode ray particles? They are electrons. They are negatively charged subatomic particles that have a mass that is much smaller than even the tiniest atom. So the stream of cathode ray particles, now known as electrons, would bend when an electric or magnetic field was brought near it. The stream bent towards a positively charged plate and away from a negatively charged plate. So what charge do electrons have? It's bending towards a positively charged plate. Then we know it has the opposite charge as a positively charged plate, which means that it is negative. So how do we know that these cathode ray particles, or electrons, are not just charged atoms? When we sent charged atoms through the cathode ray machine, even the tiniest atoms were not deflected by the charges that caused the stream of electrons to bend. So that tells us that atoms are much heavier than electrons. Electrons are a subatomic particle, meaning they're a lot smaller than atoms. So electrons must be much smaller than atoms. In order to create enough of a force to get the stream of charged atoms to bend, we had to make the charge on the electric plates 1,000 times stronger. So how big must an atom be compared to an electron? And you'll notice that you can select multiple things here, and a lot of times when I have you able to select multiple things, you are going to select all of them, and they're all true. So yes, an atom is at least 1,000 times bigger than an electron, and an electron is at least 1,000 times smaller than an atom. So there you go.